Alright, should have pencil and paper out ready on your desk. Go ahead and get started taking our notes on direct variation. This is section 3.4 in your textbook, so I'll pause here for a second and give you a chance to get everything ready to take notes. Alright, our direct variation is described by an equation of the form y is equal to kx. And so make sure that you're getting the stuff that I highlight here. The y equals kx, definitely want to get that jotted down. That when I see anything in this form, I know that I have a direct variation. It illustrates a constant rate of change. Okay, so what that means is if I have a constant rate of change, then I have a linear equation. So all direct variations are going to give me a line when I graph it. Okay. K represents the constant of variation, which is also called the constant of proportionality. Okay, so this is what kind of dictates what's going on with my graph. All right, so make sure you get all of these highlighted things jotted down here from this first slide. All right, so in my directions here, I want to name the constant of variation, and then I want to find the slope of the line that passes through each pair of points. Okay, well, naming the constant of variation is very easy if I know what the general form of a direct variation is. My y is equal to kx. Okay, so here's your general form. Here's the equation of the line given. Y is equal to negative 4x. So comparing these two, what takes the place of k in this equation? Because k is what represents my constant of variation, or constant of proportionality as it is sometimes called. And so the negative 4 is what's replaced the k, so my constant of variation is negative 4. That's as simple as it gets. Okay, you don't have to do anything. Just look at the equation and know, all right, whatever the coefficient of x is, that's my constant of variation. All right, then the second part of this said to find the slope between the 2 points on the line. And so I would take my points and label them x1, y1, x2, y2, and plug them in to the slope formula and find the slope. And so constant of variation is negative 4. Plug in your values here and find that the slope is also negative 4. All right. Let's look at another one similar to this. Same directions. I want to name the constant of variation and then find the slope between the 2 points. Here's my equation for the line, and what is taking the place of k here is the 1/2. Okay, so my constant of variation is 1 over 2. Then I want to find the slope of the line that passes through the points. And my point here is 0, 0. So I'm finding the slope between 6, 3 and 0, 0, which you see being done here, and it's found to be 1/2. And it's not a coincidence that in both of these graphs, our constant of variation has matched the slope. Okay, the slope, the constant of variation are the same thing. So that's another way for us to refer to this k value. I can call it the constant of variation, I can call it the constant of proportionality, and I can also call it slope. Okay, so pause here, and I want everybody to get this little image jotted down, because you're going to see this k value referred to in all of these ways. So I want to make sure that everybody's got this jotted down. All right, so the next thing I'm going to do with these direct variations is I'm going to graph them. Okay, and what I want you to get written from this top slide here is that the graph of y equals kx always passes through the origin. Always passes through the origin. Okay, and we're going to use that and what we just talked about in the last slide, the fact that the slope is k, I'm going to use those two things to help me graph this line. Okay? So, first of all, I look at my equation and I identify the slope and write it as a ratio. So -6 as a ratio gives me -6 over 1, which gives me a rise and a run. That's why I'm writing it as a ratio, because I want the rise and the run values. Alright, my second step in graphing this is, since I know that all of these pass through the origin, I'm going to plot a point at 0, 0, right here. Then from that point, I'm going to use my rise and my run. Okay, my rise has a value of -6, so I'm going to go down 6. My run has a value of 1, so to the right 1. Plot a point there, and then draw your line. And it's going to be the same thing every time. I'm going to identify my slope and write it as a ratio. I'm going to graph the origin and then use my slope in step 3 to find another point. Okay, so this is, in my opinion, the easiest way that we've looked at graphing a linear equation up to this point. So let's do a few of these together. And I'll pause here and give you an opportunity to get some graph paper out if you'd like to do that, because we are going to be doing a few graphs. Okay, so we want to graph y is equal to 6x. There we go. It's going the wrong way. So the first thing I want to do here is I want to identify the slope as a ratio. My slope is 6 over 1. So this is my rise. This is my run. Second thing I want to do is to plot the origin, because all direct variations pass through the origin. And then the third thing that I want to do is to use my rise over run to plot another point. So from the origin, I'm going to rise 6, run 1, and plot a point there. And then, lastly, draw a line through your points. Okay? Let's try another one. Okay, y is equal to 2/3 x is our original equation here. So my slope value has already been written as a ratio. So number 1 has already been done for me, really. I've got a rise of 2 and a run of 3. Let's identify that as being slope. Then my second is going to be plot the origin. Third step, use your slope. I have a rise of 2 and a run of 3. So go up 2, right 3, plot another point, and then draw a line through your points. Let's try one more. And here's your original equation. Okay, so let's take a second here. Go ahead and pause the video and try to do this one on your own. Okay, let's see how you did. First thing is, find your slope value and write it as a ratio. This one's already been written as a ratio, so I'm good there. Second thing to do is to plot the origin. And then I'm going to use my slope to find another point. Okay, so I can either go down 3, right 4, like so. 1, 2, 3, 1, 2, 3, 4. Plot a point there. Or I can go up 3 and left 4. And both of those have the same slope value of negative 3/4. And then once you get all your points, draw a line through all 3. Alright, that's all there is to graphing direct proportions. So let's just kind of get a little summary of graphing and direct proportions in general. I have the general form of y equals kx. My slope can't be 0. It always passes through the origin, and it's going to look like one of these two graphs. So let's again pause here, and I'd like for you to get these bullet points and sketch these little graphs here of the two possibilities with a direct variation equation. All right, let me check on my time real quick here. See how much time I got left. Alright, I don't have quite enough time left on my 15-minute limit to do this last little bit, so I'm going to go ahead and switch to another video here.